Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, everyone. Welcome to today's AI for Manufacturing webinar. My name is Lihui Wang of KTH Royal Institute of Technology, located in Stockholm, Sweden. I'm the curator and moderator of this webinar series. The topic of today's keynote is Multiverse Barrier Free, a new era for human-machine interaction for manufacturing. We are fortunate to have Dr. Youichi Nonaka today with us to present this topic. Dr. Nonaka joined the Production Engineering Research Laboratory of Hitachi in 1992, working in R&D for industrial robot application systems, digital engineering technology, and production control technology. He was a visiting researcher at the MIT in 2001, assumed his current position as a senior chief researcher in the Center for Technology Innovation Production Engineering in 2015. In the area of smart manufacturing, Dr. Nonaka has been promoting joint research with the Hungarian Academy of Sciences since 2007. He serves as an international expert and a representative of Japan to ISO/IEC international standardization activities since 2014. He is a member of a Germany-Japan IoT collaboration among Japan Robot Revolution Initiative Council, RRI, and the German platform Industry 4.0, PI 4.0. Since 2015. As the German National Academy of Science and Engineering architect in 2019, he promoted a Japanese-German industry academia expert discussion on the new relationship between humans and machines in a digital society, and co-edited the architect discussion paper. In 2017, he served as the director of the Manufacturing Systems Division of the Japan Society of Mechanical Engineering. Since 2018, Dr. Nonaka has been an adjunct professor at the Graduate School of Informatics, Kyoto University. Dr. Nonaka received his doctorate degree in engineering from the Tokyo Institute of Technology in 2011. He is a member of the Japan Society of Mechanical Engineering, the Japan Society of Precision Engineering, the Society of Instrument and Control Engineers, CIRP, and the Japan Academy of Engineering. Ladies and gentlemen, please join me in welcoming Dr. Nonaka to the virtual platform. Dr. Nonaka, the floor is yours.
Thank you very much, Professor Wang. So thank you very much also inviting me to making a presentation. It's a great honor. So let's start my presentation with a slide. This one. Yeah, today's my presentation named the Multiverse Barrier Free New Era of the Human-Machine Interaction for Manufacturing in Digital Society. It contains of the three major discussion topics. The first one is revitalize human-machine interaction. And as a kind of application method, I'd like to introduce the item 2, digital encapsulation of know-how. And the last part is a case study of those discussion items. Firstly, let me introduce a kind of a Hitachi vision. Our vision is realizing a society 5.0. Maybe you know what is a society 5.0. It was proposed in Japan 5th Science and Technology Basic Plan as a future society in Japan, and it means a human-centered society that balances economic advancement with resolution of social problem by a system that highly integrates cyberspace and physical space. So with this, the Japan's policy, Hitachi contributes to realizing a society 5.0 with five key pillars like health, mobility, manufacturing, infrastructure, and financing. And this is a kind of our strategy. Of course, the sustainable development goals and the society 5.0. We are conducting a social innovation, bringing together many ideas through the collaborative creations with many stakeholders. Regarding this policy, today's discussion are what should we do to realize a sustainable society while preserving the global environment. This is a kind of a discussion topics of today, and especially today, I'd like to focusing on the labor structure with aging society or something like that. Next slide indicates a kind of labor structure change by automation. This chart is prepared by the McKinsey Global Institute. It means a forecast of the increase and the decrease in labor by country from 2016 and 2030s. In this chart, you can see the very small characters like professionals, technology professional, or something like that. It means a kind of a category of the working type, like accounting manager, engineers, and scientists and academia, something like that. And you can see the some pillars name like United States, Germany, Japan, China, Mexico, India, or something like that, and with some colors. And the red color indicates expected to increase by automation, and blue color indicates expected to decrease. And I categorize those small chart by three major categories you can see in this slide. The top is occupied with blue. It means increasing requiring specialized knowledge. But if you see at the kind of a bottom, the record of the other jobs, including a specialized mechanics and repair, the emergency force responder or something like that. It also indicates a kind of blue and red. It means a low skilled labor remains in the future. But if we see the kind of a middle, we can see the many red areas. It means a decrease requiring medium skills and cognition skills by automation. This is a kind of a future outlook predicted by McKinsey. Next slide indicates a kind of also the other discussion predicted by Mr. who judge and instruct AI, and those who work under the instruction of AI. But this discussion should be discussed in detail because of there are kind of pros and cons are there. With the rectangles, you can see at the left side in this slide. I must say the pros is with this image, the no skill required and compliance with working conditions and no power and sexual harassment. This must be a kind of positive thinking about to apply this image, but we can see that easily a kind of a con-side, like a wedge decline, the node interaction between humans and evaluated for performance as a kind of a parts. So I must say that these pros and cons discussion impacts the human in lower layer. Something like this discussion. Then what we should do in the future society? I can say the world that has dramatically increased the labor productivity through the mechanization and automation. On the other hand, the world that has a changed labor structure through mechanization and automation. So how should human and machine interact in the future digital society? This is a kind of essential questions to you. So we mean the Professor Kahneman, originator of the Industry 4.0 in German, and I had a kind of a joint project named the Acatech, Germany-Japan joint project. You know, the Acatech is a National Academy of Science and Engineering Germany. The project name is Revitalizing Human-Machine Interaction for Advancement of Society. The project member, you can see at the right-hand side of the slide, there are so many participants from Germany and Japan, including academia and company person and something, and also the kind of IDM of Germany. Here is a kind of a promotion video of what we did.
Since the Industrial Revolution, companies have strived to standardize production in an effort to manufacture more products at greater speed, but this has now reached its limit. These days, the declining population has diversified workers, and their capabilities are also varied. In the world of machines, too, old machine tools are being used alongside AI robots. With the growing diversity of people and machines, what kind of next-generation system do we need in the world of industry? Conventional diversity measures faced a variety of problems. For example, all kinds of people work at factories. There are differences between them in their physical strength and experience, so setting a standard based on a single person will increase the burden on others. On the other hand, if everyone only did what they were good at, there would be no growth or exchanges between people, which is not an ideal way to work making use of diversity. This is also a problem between people and machines. For example, in state-of-the-art factories, machines are increasingly assisting people, and automation is progressing due to recent developments in robot technology and AI. But it's a known fact named learned non-use that when people rely too much on machines, their capabilities start to degenerate. This degeneration in mental and physical capabilities may render them incapable of dealing with unexpected problems, and as a result, they may even lose their motivation. This is not conducive to the creation of a sustainable and prosperous society. That's why we came up with the concept of multiverse barrier free, in which people are offered support in areas where they have difficulty while making use of their natural abilities. This achieves growth while maintaining diversity. Now, look at an example factory which has multiple steps of manufacturing. The process involves 3 steps. First step is measuring. The status of each process are monitored by IoT technologies. Then, it was found that the production capacity of one process was lower than the others. This is a bottleneck of the whole line. Next step is harmonizing. The new production plan with on-time delivery is calculated for accepting the bottleneck capacity instead of eliminating it. The speed of other processes are adjusted to the bottleneck so as not to generate in-process inventory, taking into consideration the learning ability of workers. However, in this way, it cannot bring out the maximum ability of other processes have originally. The last step is sustainable growth. For workers and machines that need skills, the know-how of highly skilled workers and machines is transmitted in such a way that they can make good use of their strong and weak points. For example, for workers who are quick in operation but have little knowledge, work contents and tools are informed in a way that does not impair the speed of movement. On the other hand, for workers who are rich in knowledge but not good at complicated movements, the timing and the degree of power input are indicated to support their proficiency of actions that make full use of their knowledge. Even machines will complement and enhance each other's characteristics, such as communicating the knacks that the old machine has cultivated over many years to the new machines. Furthermore, workers and machines also evolve to each other. As the machine autonomously responds to various characteristics of workers, such as changing the approach direction according to the dominant arm, it may be possible to produce high-quality products regardless of what workers and products come. In this way, both people and machines can mutually enhance their abilities and continue to grow while making full use of their various characteristics. The world is becoming increasingly diverse. To ensure the sustainable growth of the economy, we must realize a world in which people find fulfillment in their work, while evolving hand in hand with machines.
This is a promotion video what we did in Akatech project. And this is a kind of a summary of the proposal of that project. This slide contains a kind of a phase-by-phase growth of interaction between the human and the machines. You can see that in this slide, the past, present, future of the status of the interaction among the human and machines. The past is the kind of technology transition can be happened among the humans. The technology and the skills are from human to human directly. At the present status, we have too much support coming from the machines to humans. It may cause a degrading of human ability due to the too much support from machines to humans. This is a kind of a social issues of the present. What we focusing on. For the future, we imagine the share the wisdom and help each other among the human and machines, not to replace humans with machines. Again, the humans and the knowledge gained from the interactions among the human and machines, and machine and machines. And in this situation, we call the kind of some advising functions named the multiverse mediation that can realize a mutual aid among the human and the machines. This slide is a kind of a detailed discussion as regarding a multiverse mediation and about let's we think about the well-being and the planetary boundaries like SDGs. Let's imagine that in the 2050, the population of us is up to 9.8 billion. In this situation, everyone seeks the happiness and approaching the permissible limits of the global environment. This is one of the very big social issues of us. So for the sustainable development of the human society, we need the further efficiency in the lives of all the human beings and the mechanism for the sustainable accumulation and the utilization of the knowledge. According to the project, the Multiverse Barrier Free, we eager to need mechanisms for the mutually accumulating and utilizing experiences and knowledge with machines, which have already become an indispensable external storage device for human beings. This is a kind of a detailed discussion of that project. How to build a kind of a world. The essential point is make the knowledge and experiences machine readable and provide each human machine an appropriate wisdom. The left-hand figure indicates a digitalization of the knowledge and the experiences that can be understood by both human and machines. This is a kind of a detailed discussion of the machine readable of the interaction among the human and machines. And when you can see the kind of right-hand side, this is a kind of provide the wisdom to machine and humans. It requires a timely and appropriate wisdom tailored to each person and machines. And to build this world, we need a kind of a standardization and operation in international organization like ITU. And then how to create the humanity and the individuality. I believe under the coexistence with machines, we we establish a world where everyone can demonstrate their creativity and contribute to society through the AI and machines, and also a world where everyone can enjoy leisure and demonstrate individuality with the support of AI and machines. Next discussion is a kind of application method of what we discussed, item 1, named the digital encapsulation of know-how and secure distribution. This slide indicates a kind of maybe you know the system architecture proposed by Platform Industry 4.0 as a kind of a smart manufacturing system. It consists of information networks and the control networks, and between them and global shared data will be established by governments, hopefully globally. And the plug and work technology will be established among those networks and assets. This is a kind of a Platform Industry 4.0 architectures. And according to the Multiverse Barrier Free project, we have been promoting this system architecture named the digital encapsulation of know-how. This is a very similar with Platform Industry 4.0 architectures, but our essential point is that we can share the knowledges of each factories and the workers into the one single asset. Regarding the digital encapsulation of the know-how and the secure distribution, the purpose is to realize a multi-site development, technology transfer, and asset sharing, know-how service standardization, and etc. Those are the ultimate goal and the purpose of this digital encapsulation. And this slide indicates a kind of a detailed discussion. What is a digital encapsulation of the know-how? Now, we must extract useful information from a human-machine interaction and the digital encapsulation of know-how securely that can only be viewed by those who used it. A know-how that could only be transmitted through the documentation and relational formulation in the past can be securely transmitted in a wide dynamic range digitally, such as video, vibration, and tactile sensing as a benefit of digitalization. This digital encapsulation is one of the useful methods to realize a multiverse barrier-free project images, as we discussed previously. Also, we conducted a kind of a proof of concept study with a dynamic virtual factory. It consists of the based on the platform industry 4.0 architectures, including a company A MES manufacturing execution system and the company's B1 with machine Y with company A's know-how and machine Z with company's B's know-how. And we studied a kind of a transmission of the company's A's know-how from company A to machine Z of the company B's asset. This is a kind of a dynamic switching of the process owner from company B to a company A, like a dynamic machine sharing with a secured know-how switching. This is a kind of actual, one of the actual experimental result of the switching of the know-hows from company B to company A with some real cutting machine, machine Z and the machine Y. We established a kind of a manufacturing know-how sharing with compensation of each machine's individual unique error, like a deviation of the accuracy or something like that. And this is a kind of a promotion video of the proof of concept.
To facilitate new manufacturing, we need to connect production facilities together. By doing so, such facilities can respond to unexpected changes in production volume. We will involve hardware ventures in this network. By connecting with facilities and knowledge of production and maintenance, we will make it easy to customize products to users' needs, such as artificial arms and legs. This will create more effective products that can be used for a longer period of time. In addition, we will involve those who have ideas but no manufacturing facilities and know-how. By connecting manufacturing know-how and sales channels, we will help users create community vehicles and other innovative products that meet the needs of local communities. By sharing manufacturing facilities and knowledge, we will make it easier for newcomers to join the manufacturing sector.
This is a kind of our images of the digital encapsulation of the know-how. With those results, we made a news release 5 years ago with some colleagues of Germany and Hungary, like this one published by Hitachi. Last discussion is a kind of a case studies, what we discussed today, revitalize human-machine interaction and the digital encapsulation of the know-how. Currently, we have a kind of a big solution concept named the 4M data-driven approach to establish the multiverse barrier free with the digital encapsulation of the know-how. And our approach is a kind of a 4M, the man, machine, material, and method digitalization with some devices like PLC and sensing the facility movement, the sensing logistics movement, and worker movement and behavior. By multiple sensing, we can get a kind of metadata from the manufacturing shop floors, and we can accumulate those data into the one for the useful to extract useful information in a kind of a factory-wide or company-wide by some method. This procedure we call the kind of the digital encapsulation of the know-how study. Once we establish the digital encapsulation, we can establish the secure transmission of the know-how from the factory A to factory B through some applications such as manufacturing execution system or enterprise resource planning to the rapid startup of the production, using the know-how of the factory A in factory B starting up, or something like that. This is a kind of current our solution concept named the 4M data-driven approach for the multiverse barrier free. Regarding this one, please see the one video.
At the Hitachi Group, we are engaged in solving a wide range of issues in the manufacturing sector. Among these, one important issue is to prevent the occurrence of defective products on the production line in advance. With the full-scale advent of the IoT era, higher levels of advancement in manufacturing are advocated through monitoring of manufacturing equipment and detecting signs of equipment breakdown. However, we question this. Are equipment and machinery the only things at the actual manufacturing site? In addition to equipment and machinery, Hitachi is also focused on people who have evolved in a wide range of cultures and have a diverse array of skills. Hitachi is engaged in reducing human errors on production lines through the optimal combination of the know-how and technology it has accumulated over many years with IT, such as camera and sensor IoT, big data analysis, and artificial intelligence. So what is going to take place in the factories of the future? Hitachi collects massive amounts of data on the movement of workers and implements statistical analysis on this data. In this way, standard data on the appropriate movement of workers can be created. By monitoring the state of production lines in real time, it becomes possible to effect rapid detection of abnormalities and implement corrective action without stopping production lines. The production site is monitored based on standard reference data of worker movements. This technology has the potential to reduce human mistakes on production lines and to bring about major improvements in the efficiency of a wide range of manufacturing sectors worldwide. In addition, it will also result in providing support to site managers and workers and help in the training of human resources. The Hitachi Group utilizes its IT and manufacturing know-how and technology to support smarter operation of manufacturing plants worldwide. We solve the issues facing our customers and contribute to higher quality and higher efficiency in manufacturing environments. Smart manufacturing, created through Hitachi
This
Technologies.
is the overall image of the 4M data-driven approach. And the next slide serves a kind of a real application scene in a real society. This is a kind of a real application to our customers. The customer motivation is that they cannot know what caused the module quality failure, even if they are looking at the material condition, work record, etc. So we established a kind of a 4OM data approach system among the assembling workers and some equipments to catching a kind of a worker behavior and interaction among the workers and facilities. That if the worker behaves a kind of abnormal behavior, then it might lead to a kind of quality failure of the key parts of the customer's production. So this is a kind of a very useful approach to the improving of the production quality. This application has already serving to the multiple customer of the Hitachi Group. This is a machining shop floors, even if they are looking at the kind of machine historical data. So with this issue of the customer, we established a kind of a 4M data-driven approaches, including machine operation data, materials workpiece data, work instruction data, and the workers' behavior data. To bundling up with 4M cross analysis services. And this video is served by one of our key customers, Okuma Corporation. They are very famous of their machining vendor in the world. Another case study is just a kind of research in progress with this video.
To solve these issues, Hitachi is developing a management system that uses a clothing-type sensing device. Workers simply wear work clothes with built-in sensors. 15 sensors throughout the body measure body movement, and skeletal information is estimated. Furthermore, AI analyzes such predefined indicators as joint angle and duration of the load in real time. It visualizes the load on a worker's body. One of them is the load for each type of work. If you compare various types of work, you can see that floor wiping and tightening screws have heavy loads. During these types of work, adjustment of the work amount can be made so that the load does not accumulate too much. The data is aggregated throughout the day, and the load information for each employee can also be obtained. It is possible to allocate work in a well-balanced manner to reduce the load, or have workers receive medical checks to prevent injuries and illnesses.
Yeah, this is a kind of a still research in progress as a kind of one major case study. This is the kind of a conclusion we discussed and presented the revitalizing human-machine interaction for the advancement of society. And as a kind of the application method of that, I introduced the digital encapsulation of the know-how and the secure distribution. And we saw and studied some case studies of those discussion items. Thank you very much for your attention.
Thank you very much. Thank you, Dr. Nonaka. So you provided a very insightful, very inspiring talk today. I hope the audience also very appreciate this talk, and you can take some time to prepare your questions, use this opportunity to discuss further with Dr. Nonaka. And in this talk, Dr. Nonaka presented a very interesting system. This is based on the project Multiverse Barrier Free, and also introduced the 3 steps through measuring, harmonizing, and sustainable growth in order to balance the physical strengths and the knowledge skills of the workers. And eventually through multiverse mediation to increase the diversity of the workforce. I have one first question, perhaps I can put it on the table, we can discuss. Society 5.0 is very promising. That could be the future for us, how human and machine, human in the society work with the technology in a sustainable, harmonized environment. We also hear this industry 5.0. In your view, what's the difference? What is the relationship between society 5.0 and industry 5.0?
Yep. This is a very good point for discussion. Actually, from the 2016 or 2017, we Japanese representatives have been discussing about how to realize or sustainable society with European colleagues, with including a German representative, like coming from the Acatech. And they are pretty much interesting about the discussion about what is society 5.0 promoted by a Japan government. And we did a kind of some detailed discussion for the similarity and differentiation between the industry 5.0 and the society 5.0. The differentiation is very small between the industry 5.0 and society 5.0, but a kind of a way of realization is a little bit different, I can feel. This is my personal feeling. For example, we have to respect for each cultural background or way of thinking. That we have a kind of many diverse thinking and a diverse cultural background for each country and each region. So even if the ultimate goal of the sustainable society is a very same, but the way of thinking or how to realize to achieve the sustainable society may a little bit different for each countries. So we agreed kind of a similarity and differentiation in the discussion of the way of thinking of how to realize, like worker program or educational program or green program might a little bit differentiate among the countries to discuss or to reach a kind of a ultimate goal. This is a kind of a real discussion result between the European colleagues and the Japan and the Asia colleagues.
Thank you. I understand that both Society 5.0 and the Industry 5.0 highlights the importance of human centricity.
Exactly.
Human centricity has been mentioned in Society 5.0 and also mentioned in Industry 5.0. That could be the point that in the future, humans still need to be in control, no matter in industrial setting or in society. And in your presentation, I see the harmony. Looks like the technology and the human workers is one, united one. How do you consider that this human centricity dimension in Society 4.0?
Yeah, this is a very big discussion we did with our German colleagues. The German colleagues, like Professor Kangaman said, the German colleagues has a kind of a big discussion between the worker union and some technology engineering for the automation. So there are kind of mind barriers to apply some automation technologies to real shop floors operated by human. Some worker union feels a kind of a negative feel for the automation with robot or some sensing device or something like that. They are very much respected to kind of their traditional way of technology. So we have to solve the kind of how to merge the kind of how to say the technologies and the humanities between the traditional way of the German or way of the European colleagues or the way of Asian colleagues or something like that. There is a kind of a big challenges. It is still the open issues, I feel.
I'm looking for some questions from the audience. Haven't received any yet. So I can continue with another question. In your presentation, you talked about the dynamic virtual factory. Different companies can work together, share their knowledge, their skill to create this virtual factory. And this is very good, especially for end user. They benefit a lot from the knowledge sharing. For the company involved in this virtual factory, how do they feel? How do they share the benefit or share the risk in terms of security risk, privacy risk, competition, and so on, and how they share profit? You must have some measure to handle this issue, right? Maybe you can share some insight about this.
Yeah, the virtual factory, what we presented maybe the 2015 in the IEC white paper. At that time, this is a kind of a future image. But at present, we can see that a kind of a lot of similar businesses in the real world, like a matching company with a kind of engineering issues having, and a kind of a manufacturing site that can accept some engineering with multiple stakeholders, with secure digital communications through the internet. So also the kind of one of the Hitachi Group company has been conducting like matching services between the manufacturers and the engineering producers. With a kind of a very secure internet protocols with a kind of Hitachi's services of the as a kind of infrastructure. So as a kind of images I presented today, there's a kind of very open platform ecosystem, including a kind of a manufacturer or engineering producer or IT platform vendor or something like that. But last, again, the 7 years, so many similar businesses have occurred in globally. This situation, I believe, a kind of grown in also in near future.
Yeah, it's a very challenging task. We have one question from audience. The question is from Dos Blanca Pazaran. With the innovation technologies you presented, what are the KPIs and outcomes in workers' productivity and manufacturing efficiency?
Yeah, this is also the kind of a very good discussion. Since I am a kind of international expert and convener of the IEC, ISO standardization initiatives about the smart manufacturing, we are very much respect to the kind of standardization for the manufacturing efficiency as a kind of a KPI list that can be shared among the multiple stakeholders. Maybe you know the IEC and ISO has published a kind of some standardization format for the engineering workers' performance as a kind of several KPIs. So our system has involved this standardization format to share a kind of performances with one measure.
Okay, thank you. There's another question from Jin Cui. Thank you for the lecture, Dr. Nonaka. Have you ever heard of cloud manufacturing? The digital encapsulation of know-how and secure distribution has some similarity to the idea of cloud manufacturing. It is a kind of smart manufacturing mode aiming to achieve massive individualized manufacturing through sharing the manufacturing resources and the capabilities. So that's a question for you.
Yeah, yes, this is we initially we promoted this concept named cloud manufacturing. This is a kind of, again, this is a kind of ecosystem of the smart manufacturing with multiple stakeholders, including some manufacturers, the engineering producers, and the IT developers, or something like that. Again, recently, so many business business persons has launched a similar concept, especially in the COVID-19 situation. So we have many inquiries for the collaborations of those, such as those open ecosystem establishing in the Asia side, European side, or United States side, or something like that. So again, this is a kind of ongoing project globally.
Thank you. So if you have any follow-up question, you can also continue. Now we have another question from Jivat Ram. My question is about a machine being creative. As you mentioned that in the human machine setup, machine will contribute through knowledge and creative ideas. How that they can be achieved? This is an interesting question.
Yeah, this also this is a kind of a very good good question. I believe like a kind of a smartphones we are utilizing daily, like TikTok or like some SNS methodology. We actually have a kind of some inspirations as a kind of a creativity for the human well-being or something. Also, we are thinking about the planetary boundary through the SNS. This situation is also, we believe, a kind of creativity coming from the interaction among the human and the machines, something like that. We believe, Germany colleagues and the Japan colleagues believe the machining or assembling robot and workers can create a kind of a new ideas for the sustainable manufacturing for the digital society. This is a kind of our images coming from the kind of what we are doing through the smartphones with a SNS or something like that.
Yeah, thank you. Looks like our audience is very active now. There's two more questions. I will go first for the earlier arrival. This question is from Zeri Christoph. How do you manage the privacy of workers if they are constantly monitored?
Yeah, this is also the very good discussion, a good point to discuss globally. Again, we have a kind of a various way of thinking to making a kind of a security through the digital infrastructure like internet or something like that. And you audience can easily imagine there's a kind of a very different way of securing for the personal data or something like that. Easily, there is a kind of a very big differentiation of the thinking between the GDPR in Europe, and there is a kind of a a little differentiation of the thinking of the Asia side on the United States side or something like that. Of course, the kind of emerging technology should fit for each country's rules and regulations. So that this is a kind of instance discussion for each country's application. This is a kind of a real business situation.
Okay, thank you. There's another question from Jay Harris. Thank you for the interesting insights within the 4M framework. Is there space to gain feedback from workers in less structured ways? That is with survey, feedback sessions, conversations, shadowing, as opposed to data gained from sensors. In my work, I have found a lot can be gained from simple talking to the people doing the work day to day that is not captured by sensor and structured data capture.
Yeah. The question is quite right. We have a kind of various feedback channels from the result to worker or manufacturing quality improvement. As a kind of a traditional one, that we have a kind of a tailored approach or something like that. But a kind of with some digital devices like vibration sensing or video sensing, we have a kind of another channels coming from the digital data to workers quality improvement or machine quality improvement with some analytics via AI with a kind of a very secured IoT infrastructure. Again, there is a kind of a multiple way of improving for the manufacturing quality.
I hope this addressed your question. Now we move on to another one. This is a new question from Dulce Panzaden. What are the top strategy in upskilling of workers so they will be more prepared for Industry 5.0?
Yeah, great discussion. My presentation of today is a kind of just a kind of application example and study to cover the Industry 5.0 and the Society 5.0 in Japan. We have to think about a kind of another social issues like manufacturing or energy resources or material resources or environmental issues or poverty or happiness or something like that. But at least a kind of a case study, the result of the case study in smart manufacturing, I believe that we can expand this case study to another industry domains like financing or mobility or something to realize the Industry 5.0. So that's why we are discussing with European colleagues.
Very good. So in the chat area, I do not see more questions, and also we are good on time. If you have a first question, you can ask. This is a last chance. Otherwise, I think I can summarize and finish this webinar session. So now I think it's time to wrap up today's webinar. I would like to thank Dr. Nonaka for delivering this wonderful keynote today. And I also wanted to thank all the online audience for your very active participation today. The next AI for Manufacturing webinar is scheduled for February 6th at 5 p.m. Central European Time. Dr. Mehra Narayan of Emerging Tech Sustainability GTM Tata Consultancy Group will present on AI and digital twins use cases driving sustainable manufacturing. Please stay tuned. Have a great day. Bye for now.
Thank you.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.